Alright, for the third part, we are going to look at different types of sets and learn some vocabs or some terminologies we might use with them. First, we have this. We can divide the set into groups that that express elements in different ways. Like for instance, not for instance, sorry, that there are two ways to express the elements in the set. Like first is the thing that we call explicit. And I know that there are so many definitions for explicit, but let me stop there for a moment. And on the other hand, it could be implicit. For the explicit one, you may get that from the definition itself. Like it explains, it says, it lists anything, it lists everything there is to a set. For instance, you can say, okay, the set A has elements 1, 2, and 4, or the set B has elements 1, 3, 5, 7, and so on. Here, for these two examples, you see all elements inside those sets. And that's 1, 2, 4. That's 1, 3, 5, 7. You see dots. That in this case, it is easy to deduce that, oh, there must be the set of all the odd integers. That's one way to explain that. That's one way to express the sets. Another way is to express them implicitly. Like this is what we did in the first example for the set comparison. Remember the examples when we talk about sets? Like for instance, let's say be the set of we can say let's say be the set of letters in English alphabet. Now that's one way. English alphabet. That should be small. That's one way to describe the set. Here you don't see any elements at all. Just a set and some description. Right, but nevertheless, it's a set. It is well defined. We can, if we have enough time or if we want to, we can convert that into the explicit one. Right, but there's nothing there yet. Right, so that's what we call the implicit one. Or sometimes we want to explain, we want to write in terms of set, right, to make it a formal math. But we write some more definition here. For example, this could be the set of all animals that has 4 legs. And here we introduce a new notation, which is this line, this splitting line. You should write. Not you should, but you read that line as that. Right? I think you want to list all the elements, like in the first part that satisfy the condition on the right hand side of this line. In this case, you would translate that into the language that says these are a set of all animals that have 4 legs. Right, so you split them. So this set says 2 things about the elements. First, it says the scope. Like this would be served as a universe in this case. Like it's kind of universe. Like we start from animals. Right? We are not talking about plants or people or anything. We're talking about animals. And then we want to look at animals that has this property that satisfy that requirement. So that would make the set smaller. They all might be the same size if everything satisfies that requirement, but usually the set becomes smaller. And that's how you write that. Or even in more math term, like this doesn't look math. Like in more math term, you might write something as, let's say E is the set of X. Oh, sorry, it doesn't say where. That sorry, it says where. List of all the animals where they have 4 legs. Or that and a kind of a synonym. In this case, it might be more appropriate to use the word that. Yeah, but in math we use the word where. of 10. Like in this case, you want to list all the element, all the x, right? All the variables where let's say x is positive, for instance. And that's one way to write the set implicitly. Like you don't write every number that is positive right in this way. Or maybe you want to specify, for instance, we can write f is a set of all the x that let's say x that is integers, so if they are whole numbers, where now this will make more sense where x is even. Like for instance, that is also another way of writing elements. Right, this is like the let's say the format or the first requirement, and the scope. We start from here, and then we narrow it down. We make it smaller by giving more conditions on the right hand side. So this is what we mean by writing the sets in implicitly versus explicitly. So that's one way, like, to distinguish between two different sets. Another way is to distinguish them between size. Like if you count how many elements are there in each set, and you can split them into two groups. Some sets are finite, and of course we can call them finite sets or finite sets. In this case, the finite sets are sets where the number of elements of the set or the size of the set is finite. Which doesn't say much, but in this case, finite means it's just a number. Or in this case, since we count things like this, a number. Yeah, let's just say a number. Like, A is a set of atoms in universe. Right. Even though there are lots of things in the universe, like physicists study them forever, and they can seem to understand everything. But one thing they know is that the amount of atoms in the universe is finite, and there may be like 10 to the 10 to the 10 to the 10 number of atoms, but that's still finite. No, it's just a lot. Right? Or we can write it as B is a set of money that you have, which is of course finite. Oh, I can use a soundboard. Damn. So that's a finite set. And if it's not finite, then it is infinite. Yeah, and the fun fact in English, like when you say finite, like you stress the word nice, like finite. But for here you stress it on the infinite. Oh, sorry, on the word infinite. It needs some practice, like finite, infinite, like not infinite, or all those pronunciation. Right, it could be infinite. Like for instance, you could say, okay, let's say we a set of integers, or let D be a set of prime numbers, and so on. So yeah, that's simple enough. But again, that's maybe this might be a new keyword for some of you. Then we can distinguish the sets by size, or we can distinguish the sets by continuum. Pretty fancy word, right? But what do you mean by that is a set could be discrete or continuous. And again, this was a kind of jarring. They are technical word. And what we mean by discrete is we talk about things that are like apart from each other. There are things or there are objects that you can visualize them as separate objects, as separate thing. that maybe it's like you can spread them around on the floor and you can look at them all, like just numbers 1, 3, 4, 5, right? Or even the set of all integers. This is what we call discrete set. Like even though there are infinite amount of elements, like we can visualize B as it has 1, and then has 2, it has 3, and then it has 4, and so on. They are separate elements. They are apart from each other. Whereas another way to describe set is we can describe them as elements in range. Like for now it's in range, but for the advanced one there are some crazy stuff. Yeah, but for now, sometimes you have elements in range. In this case, elements that you cannot just just tear them apart from each other. Like for instance, you can think of set of the number x where x is between 1 and 2, or 0 and 1. In this case, we are talking about all the numbers that are between 0 and 1. You can think of that there are lots of numbers there, like not just 0 and 1, or which are not actually included. Oh, let's include them then. Yeah, 0 is in the set, 1 is in the set. But so 0.1, 0.2, 0.333, 1 over square root of 2, pi over e square, all those crazy numbers. They are real numbers. They are between 0 and 1. But there's no way we can just list them out. Right? For instance, you might say, we can start at 0.1. But no, right? Because some numbers are smaller than that, like 0.99. That's sorry, 0.09. Right, that's smaller than 0.1. Right, then okay, you might ask, is there anything between these two gaps? Is there anything between 0.09 and 0.1? Yeah, like 0.0995. And this never stop. If you give me two numbers, I can always find things in between them. So it is impossible to just list them out one by one and make sure that you get everything. You're not gonna get everything. Oh, and by the way, this is what we mean by uncountable. You cannot count. You cannot list them the same way as you list integers or whole numbers. And so that's the last. Not the last, but there's another set of two vocabs that can be used to describe the property of a set. And then lastly, there's some exercise that you might see. And there's only 3 pages. So lastly, when we talk about set, right, and as you can see in the example C, like mostly in most areas when we talk about numbers, we talk about numbers in between two ranges. In a range between two numbers. Right, you want to think about numbers between 0 and 1. Right, or if you want to look at people who can drink, isn't it in the age that is legal to drink? You look at people who have age greater than 18 or equals to 18. Like, if you want to flip a coin, get a chance to, or whatever, sometimes you have that x is between two numbers. And those numbers are used a lot when you solve inequalities, or when you try to split things into parts. So we need to know a little bit about that. And that is what we call an interval, or intervals in this case. And this is a commonly used notation of sets. Right? There are still sets. Right? There are sets in disguise. Right? But these are special sets that we call interval, which is kind of interchangeable, I guess. But yeah, what are the intervals? Intervals are sets of numbers. Like there are sets of numbers that satisfy some inequality. Like for instance, for the first part, like on the right hand side, right here we talk about set of, if we write it out, like you write as set of numbers. like set of value x that in this case greater than a. Oh, I shouldn't use pink. Yeah, let's choose red. Great. I can't do English. Greater. Where's my eraser there? Greater. Greater than a. And at the same time, less than or greater than or equals to a. Man, it takes more space. Greater than or equals to a. Okay, and less than or equals to b. And so that's the concept of interval. Like we have maybe 2 points, like to the lower bound and the upper bound, and if you look at everything in between, and you can see that if you write them out as a sentence, that's pretty long. And so we can use set to abbreviate that, and even better, we can use interval to abbreviate the set even further. Like we have this set, right? But since we use it a lot, why don't we, use a shorter form? And that's where we are at. Like we have the set. We have an interval a to b. Right. So for the first one, if the symbols are less than or equals, less than or equals to a is less than or equals to x is less than or equals to b, right? We use the symbol of a square bracket, which is on the keyboard somewhere. Right? And on the other hand, if you use the less than, in this case it is strictly less than, right? Then we change the symbol to the circle bracket or the curve, the usual bracket instead. And sometimes you can mix and match. You might want to look at numbers that is strictly greater than a, but could be equals to b. So in this case, it's less than on one side and less than or equals on the other side. And you can mix and match. Like since the left one is less than, you use the curved one. But since the right one is less than or equals to, you use the bracket one. And lastly, you can switch that. And that would represent a different interval. It's just, some slight change. And these 4 intervals, they actually have a name, right? In the curve parentheses, we call it non-inclusive, which is not a good word, but maybe you should remember them as an open bracket. Oh, sorry, this color confusing. Yeah, let's the open one be orange. Right, they are open in the sense that we don't get to that point. Right, we are not thinking about the point A. And that point is open, it's gone.